So in this unit, we're going to talk about circles. And one of the big reviews that we're going to talk about in circles is what we call completing the square. And so when we complete the square, what we're actually trying to do is get into a form that we can make it a perfect square factoring. And so a perfect square trinomial is any trinomial. By the way, trinomial means that you have three terms in it. So this is any trinomial that can be factored into two identical binomial. Binomial means that you have two terms in it. And they have to be the exact same. So something like this, x squared plus 6x plus 9, can be factored into x plus 3 times x plus 3. And again, remember when we factor, what we're really doing is we're undistributing. So we want to look at it like this. If you were to distribute this back out, you would get x squared, you would get 3x, you would get another 3x, and you would get 9. So here you would get x squared plus 6x plus 9, which is what you started with. But what's happening is you take this trinomial, a perfect square trinomial, you write it in factor form, and you can write it as this binomial that's being squared. So we can do that for a lot of our different trinomials. And the goal here is to make sure that we can write those type. In order for this to work, though, here's the pattern you need to pick up on. Notice that whatever this middle term is, the middle coefficient, which in this case is a 6, over here it's -8. When we write it to its factored form, this term right here, both these terms is plus 3 and it's plus 3 should add up to this right here. So literally we're cutting it in half. And then back here, it should be the square of whatever this is. If you do 3 times 3, it's going to give you 9. Same thing, -8, cut it in half, you get -4, -4. And then when you go and square -4 times -4, you get 16. So this is the process we're going to use to actually complete the square. Because most of the time, what's going to happen is you're going to have to complete the square yourself. So you'll be given part of the term, you need to figure out the rest of it. So again, in this particular case, whatever this value is in the middle, you're going to cut it in half. That'll give you this number here. And then to get the back number, you're going to square it. Cut it in half. You get this number here, square it, and it gives you this back number. So let's give this a shot. It says what term should be added to each binomial so that it becomes a perfect square trinomial. So again, if we look at x squared plus 8x, remember what we do. We would take the number that's next to the x, which is going to be your middle term, which is an 8. So we'll take 8, cut it in half. That's equal to a positive 4. Because you take whatever the sign is, put it here. And then you're going to square this. And that equals to a 16. So the term that should be added to the back is a positive 16. The back term will always be positive because you're squaring in a number. Same process here. This time you're going to take 7, because it's this number right here in the middle. It's a -7. Cut it in half. -7 cut in half is, we generally write it as just -7 over 2, because it's not a nice number. But you could call this a -3.5 if you would like. And then you're going to square this next. So when you square a negative number, you always get back a positive. And so we're going to be adding something back here. And so that's -7. Just square -7, you get a positive 49. Square 2, you get 4. So this is just 49 over 4. So now that we can do this part, we can actually go to the actual further process of completing the square. And in order to complete the square, here are the steps we're going to follow. Your first step is to make sure that the leading coefficient, and when I say leading coefficient, that is the number in front of x squared. The number in front of x squared needs to be 1. If it is not, you're going to divide every term by the number in front of x squared. That'll make that number 1, and we can work from there. The second step, you're going to isolate our constant term. And the constant term is the term that's always on the back that we were creating right here. You're going to isolate that term. So we call that the C term. And generally, the form of completing the square is you have x squared plus bx plus c, where the number in front of x squared is a 1, bx is the number you're going to cut in half and square, and c is the constant term. You want to isolate that c so you get something that looks like this. You want to have x squared plus bx is equal to, and when you isolate it, really what happens is it's going to become negative c, or the opposite of whatever c is. You want to move c over and make it a negative, take its opposite sign. And then the last step, or the next step, I'm sorry, not the last step. The next step is to find the perfect square trinomial. Find the perfect square by adding b over 2 squared to both sides. And then the last step is to factor by regrouping 2 perfect squares. So let's look at this process. If we look at number 1, notice that I already have the c on this side by itself, and it's x squared plus bx. So the first thing I'm going to do is I'm going to focus on the bx part, and I need to find the number that is the half of that square. So I'm going to do 8 divided by 2, and I'm going to square that. 8 divided by 2 is 4. 4 squared is 16. So what that means is this. I'm going to do x squared plus 8x plus 16 is equal to 1. Now, here's what happens. Because I've added 16 here, I have to keep this problem exactly the same. I need to add another 16 on this side, but that doesn't change the problem now. What I've done is I've factored this. Now, I can get this to, I can go and do step 4, which is to factor by regrouping. This right here is now a perfect square. This is a perfect square. And it factors like this. It's x plus 4 times x plus 4. And this is equal to 1 plus 16 is just 17. Because these terms are exactly the same, I can write them like this. X plus 4 squared is equal to 17. From here, we can solve the equation by taking square roots. And so we're going to take the square root of this side and this side. Here's what we get. When you take the square root of a square, you get what's underneath the square, which is x plus 4 equals. And we're going to, on this particular case, anytime you take the square root of a number, you have to do a plus or minus pair of it. Square root of 17. And so finally, to solve it, we get x is equal to, again, we want to isolate x. So to isolate x, we have to subtract 4 on both sides. So it's going to leave us with the answer of negative 4 plus or minus the square root of 17. So look at the next one. Notice here, when we start this, our process, again, is to make sure that we have a variable of 1 in the front, which is okay here. And we need to isolate the c. The c needs to move over. So in this particular case, I need to move this value of plus 2 over. To do that, I do the opposite. So I get y squared minus 5y. The opposite of positive 2 is a negative 2. Because essentially what I've done is I've subtracted it from both sides. Now that we have this set up, again, here's what happens. I take the b term, which is this term right here, and I go negative 5 over 2 and I square it. When I do that, I get, remember this is when we're squaring this, we get square the top, 5 times 5, 25, square the bottom, we get 4. So we can rewrite this as y squared minus 5y plus 25 over 4 is equal to negative 2. And because I've added it here, I have to add it in the back here. Plus 25 over 4. And now when I'm looking at this again right here is a perfect square. That's why I've done this. So this factors into y minus, remember it factors into whatever's in here, y minus 5 over 2 times y minus 5 over 2. And that equals, here, I need to get common denominators to work with this. The denominator here is 4, so I need to make this into fourths. In order to make that negative 2 into fourths, right, I just multiply 4 times negative 2, I get negative 8 over 4. And when I add negative 8 over 4 to 25, I'm going to get a positive 17 over 4. So again, we can combine these two things because they're the same into y minus 5 over 2 squared is equal to 17 over 4. Once we're here, anytime you have something like this that squared equals a number, you can take the square root of it. And when you take the square root, you get whatever's left underneath the bottom, y minus 5 over 2, is equal to plus or minus the square root of 17 over 4. Cleaning this up, we're going to just move the 5 over 2 over by adding to both sides. And I get y is equal to 5 over 2 plus or minus the square root of 17 over 4.